Okay, here we go. Chapter 6. Chapter 6 is statistics, beginning of statistics. What? This is for everybody who's not here today. I'm going to put this on haiku, and they're going to get it all on haiku later. So, statistics is the biggest topic in math studies. There's a chapter now, and there's another chapter that we do next year. This year it's called single variable stats, and you won't know exactly what that means until you see what multivariable stats is next year, and then you'll see, oh, okay, that's the difference between single variable stats that we are doing now and multivariable stats that we'll be doing next year. So to start off, it's about different kinds of data. There is categorical data and numerical data, and you deal with them differently. Categorical data is data that you put in categories like colors, red, blue, green, or types of cars, Toyotas, Mercedes, Ferraris, gender, male or female, nationality, USA. There's no numbers in there, is there? I mean, there's no answer in there that's like 4.6 meters or whatever. So categorical data is the groups that you put them in are just names, like I'm an American, or I'm a Thai, or so that's the kind of grouping you put in. Quantitative data, there's two kinds of quantitative data. There's numerical discrete data. Discrete means whole number answers only. Like, how many brothers do you have? 1, 2. You'd never say 2.5. Or, so discrete data, quantitative, discrete. So there's two kinds of quantitative that are numbers. There's discrete, which are whole numbers, and then there is continuous. And continuous means that if I ask you to measure how wide this table is, you wouldn't just say it's, if I was asking you to be careful, you'd say, oh, it's like 44.7 millimeters or centimeters. You can't go into decimals. So the discrete are whole numbers, and the continuous means exactly that. The data is continuous. It could be decimals or fractions added into the whole number part. How much do you weigh? Most of us would say, oh, I weigh 70 kilos. But in fact, if you were being careful, you'd say, oh, I weigh 70.35 kilos. So with continuous data, it's numerical, but it can have decimals and fractions. Okay, so let's talk about that now. Right now we're just talking about whether it's categorical, quantitative discrete, or quantitative continuous. Yes?
Can you go back?
Can I go back? No.
No, like to take notes.
All you need is the broad strokes. Quantitative discrete is whole number answers, and quantitative continuous can be represented with decimals or fractions as well, or should be, if you're being careful. Okay, you toss a coin 3 times and record the number of heads you get. So you toss a coin 3 times and you look and see how many heads. Is that categorical? quantitative discrete or quantitative continuous. So first of all, is it categorical or is it numerical? How many heads are you going to get? Out of 3 tosses, what kind of answers are you going to get? Whole numbers, right? So that would be quantitative discrete. Quantitative discrete. You want to get a fraction of a head. What brand of toothpaste do you use? Is that numerical or categorical? Yeah, you'd never put a number on there. You'd say, oh, I like Colgate, I like Systema. The height of a group of 15-year-old students.
Continuous.
Yeah, it's numerical or quantitative. You could say numerical, but quantitative is the best word. Quantitative continuous. So, we're going to talk about quantitative discrete first. A farmer counts the number of peas per pod in his harvest. So, he's being really picky about this, and he's looking at a bushel of peas, and they come in a pod, and as he opens up these peas, he's counting the number of peas. When he opens the pod, he's counting how many peas there are in the pods. And he got all kinds of numbers. He opened up 150 pods and noticed how many peas there were in each pod, and put it in a tally table. I'm sure you've all done a tally table. You go through, if you had 150 numbers out there and you were you're trying to organize them, one way to do it is a little tally table. And so you open up the first pod and you see there are 5 peas in there. So you come across here and you put a little tick. And you open the next pod and you see there are 7 peas in there. And you come across 7, put a little tick. And there's all 150 in the little tally table. And then you add them all up, you get a frequency. And then this column is called the relative frequency. Can you see that? Maybe not. The relative frequency is kind of like what fraction of the peas fit in each of these little groups. Are there 150 pods? There were 150 pods. And how many were having 5 peas in each pod? 29. What's 29 over 150? It's this decimal. So it's not a percent, it's a straight decimal. So what you do is you say this group was 2 out of 150, and just do that with your calculator, write down that decimal. And so anybody have a question about where the relative frequency comes in? You're not sure? You're happy with the relative frequency? Where did this 0.167 come from? What did this farmer do to find 0.167? Jerry.
The amount of pods that had 7 peas in it over 150. Good.
So the number of pods that had 7 peas was 25. So it's 25 out of 150, and there's the little decimal. And you can get sort of a little idea of the decimal or the fraction of peas that were in each pod. And then quantitative discrete data is displayed using a column graph. So you've all done column graphs probably, I hope. You might have called this a bar graph. You always put the frequency. The frequency always goes on the vertical axis, always, in everything that we do. Whenever we're doing statistics for the next month and next year, the frequency will go on this side. And then whatever data you're gathering, which is the number of peas per pod, that would go on here. So here's Jerry's 25 pods out of 150 column right there was 25 P's. The mode. The mode is the most frequently occurring value. What's the most frequently occurring value here? 6 P's per pod. So that is what's called the mode, the one that happens the most often. And if you look at discrete data, in order to show that there's no decimals in there whatsoever, they always separate the bars from each other. So with discrete data, that's why we learn things like continuous and discrete. With whole number values, you always do your bars separated by a gap. And anybody who looks at this should realize if it's separated by a gap, you're talking about discrete data. You can only have 2 P's in a pod, or 3. You don't have decimals or fractions involved. Always have the column widths the same. Describing a distribution. When you look at a bar chart, if it's perfectly symmetrical around the mode, find the mode. If it's perfectly symmetrical, it's just called a symmetrical distribution. Most of them are not a perfectly symmetrical distribution. They are called skewed. And this one is called a negative skew. If the data is bunched a little bit on the right, it's called a negative skew. And this one is called a positive skew. And that's a little bit counterintuitive, because these are kind of bunched over on the high side, aren't they? Would the numbers be bigger out here? So you'd kind of think, well, those would be the positive skew, because they're bunched up out there on the big numbers. But that's not the way it works. So if it's all kind of pushed to the right, it's called a negative skew. If it's pushed to the left, it's called a positive skew. What would you call that? It's pretty symmetrical, isn't it? Is it slightly skewed? Which way? A little bit skewed to the right? Which one's that? Yeah. You would say maybe slightly negative. Outliers. Just as you might expect, an outlier is a number that is outrageously bigger or smaller than every other piece of data. And in statistics, usually you throw away the outlying number because it's a freak, and you don't want to upset your data too much by putting in that extra person out there. For example, if I was trying to see what the average amount of money we're all carrying around in our pocket is, we're all probably carrying a couple of hundred baht. So if I went right around the room and found out how much money everybody had, it probably would average a couple of hundred baht. But if Stefan was walking in here paying his school fees for this semester later today, and he had 400,000 baht in his pocket to walk over and pay for his school fees, what would happen to the statistics? The outlier would throw all of the stats off, and it would look like we're all walking around with 15,000 baht in our pocket just because he's got such a bomb in his. So if there's an outlier going on, sometimes you disregard the outlier, and then just because you realize it's an off situation, and shouldn't be thrown in there. Okay, so can you see those numbers? You're going to make a tally table and a frequency table and a relative frequency column. You're going to do one of these. Put a tally, put the numbers down the side, make a tally, do a frequency, a relative frequency. Would you like me to read them to you, or can you see them?
We can read.
Okay. I can read it to you. Are you ready for me to read it to you? Can you see it, or would you like me to read it? Anybody wants me to read it? I can easily just read it, read the numbers. Chai-Ted? Okay. You ready to start writing? Okay. 8, 7, 6, 7, 7, 7, 9, 7, 7, 11, 8, 10, 8, 8, 9, 10, 7, 7, 8, 8, 8, 8, 7, 6, 6, 6, 6, 9, 6, 9. So you should have 30 numbers.
What is it? 2 tables and 1 line?
No, that's just all the data. So okay, so you're going to have, I'll put that all back. I will put it back. Number, tally, frequency, relative frequency,